Using the same information that we were given for question 6, now we want to calculate the concentration of hydrogen in the drink. So that's H+. So this one's going to be a little bit more work than the previous problem. So now it's telling me that pH is 1.8. So I'm using this formula, remember, that it's negative log of H+. And now instead of pH, I'm going to put 1.8. And then I'm trying to solve for H+. So the first thing I need to do is isolate the logarithmic expression. The logarithmic expression is almost by itself. I just need to get rid of this -1. So I'm going to divide both sides by -1. So I would have -1.8 equals the log of H+. Now I can put it into exponential form. Remember that even though you can't see it, there is a base 10 here. This is a common log, so I have to know that the base is 10. So this is going, and actually I'm going to rewrite it first because we're used to seeing the logarithmic expression on the left. So I'm going to write this as log base 10 of H+ equals -1.8. So now what I'm going to do is I'm going to say 10 to the -1.8 equals H+. If you put 10 to the -1.8 in your calculator, it gives you this big long decimal. We want to write our answer in scientific notation because if you refer back to the other problem, that's how they gave us the H+. So to figure out the scientific notation, what we're going to do is we're going to figure out how many times I have to move the decimal place until it's between two numbers that are not 0. So I'm going to move it over once and twice. So between the 1 and the 5, that's where I want my decimal point to be. So I'm going to say 1.6. And the reason it's 1.6 is because of this 8 right here. That would round the 5 up to a 6. And then it would be times 10. Now, since I moved it to the right, I need to make my exponent negative. I moved it over twice, so this would be times 10 to the -2. And if you wanted to double check that your answer was correct, you could actually type that into your calculator, and you could see that if your decimals match.